Hi, and welcome to this video where we will be writing the final Arduino program for our NodeMCU RC car. To get started, you want to pull up bidirectional motor control and web server non-AP. You also want to create a new program, and I named it RC car program, and it's your choice what you want to name it. Then you want to start by including the 4 libraries. Hashtag include ESP8266 Wi-Fi .h, include Wi-Fi client .h, include ESP8266 web server .h, and finally include ESP8266 MDNS.h. Now we want to create our MDNS responder. And don't worry, we'll do our pin definitions in 1 second. Then we'll define our SSID and password. And now we'll define our server. On port 80. And then we'll define our web page. And now we will do our pin definitions. Or actually, I think we don't have to define those, but let's define the ultrasonic ones. So constant trig is equal to P1, or sorry, D5, and constant echo is equal to D6. And then we are ready to go. Let's go to the setup. Now we're going to start by beginning on 115200, and we'll also begin the Wi-Fi as well. And before we do this, let's make sure our pins are pin moded and set to low. So pin mode D1 output. Let's just copy and paste this a few times. D2, D3, and D4. Then we'll digital write D1 low. And we'll copy that a few times, paste it a few times, and set them to all the pins. And now we'll do it for the ultrasonic sensor. So trig is output, and pin mode echo is input. Then we set trig to low. Now we can do our Wi-Fi fancy things. Let's just copy this. Okay. And here we are. And now we are connected. We can delete the 16 output and 16 low because we don't need that. Then let's create our server.ons. So server.on. And the first one will be forward, and I'll abbreviate it to FWD. And we'll do our usual thing. We have to put a semicolon there. So we'll set the web page first is equal to forward. Then server.send that to 200 text /HTML and web page. Then we can print it. And now we can do our pin things. So for forward to be true, we want to set D1 and D3 to high and D2 and D4 to low. So I think we can just copy this digital write block and paste it right here. This will be high. This will also be high. And I'm going to indent this just so it looks neat. We can copy this and paste it 4 more times. Actually, we'll paste it another time for the ultrasonic sensor part. So we'll start with the one that's after the forward. So BCK is backward, and it's reversed. So do you get what I'm doing for the pins? D1 is going to be the positive side of the first motor, which is on the left. D2 is going to be the negative side. So if you set D1 to high and D2 to low, that means the motor is going to go forward. And we can do this through experimentation because I'm not sure how exactly I plugged it in. But we can figure that out with the wiring once we do our final project. Now we can set left. So I'll abbreviate that all to 3 letters, LFT, and I'll say left. And for left to be true, we have to set the second motor to forward and the first motor to backward. So this will just be high, and this will be low. Simple. Now we'll do right, which will be the exact opposite. So motor 2 is going to go backward, and motor 1 is going to go forward. Then we have an interesting case, which is brake. And we have to change this as well. So brake just turns off all the motors. And for this final case, we will let it be called auto. And I'll abbreviate that to I'll just say auto because it's different. And now we have to do our ultrasonic thing. So let's go ahead and open up our ultrasonic program right here. We want to copy this. And we can just delete that. Now, what are we going to do with this? So I'm going to first just make sure that everything's indented correctly. So we know that 16 instead is trig. And this is also trig, and this is also trig. This is echo. And we can indent that, indent that, indent that, indent, 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 indent. And instead we can delay 1 just for our thing. And we're going to delete that in a second. We also don't need inches. We're going to do it in centimeters. And that seems about right. So inside here, we're going to put in a conditional statement. So if centimeters dot is less than 50, then we're going to go right. So digital, let's actually just go up here and let's find the code for right. And it's just going to keep on turning until it doesn't see something that's less than 50 centimeters. And else, it's just going to go forward. Simple. And this is just something to think about if you want to add in what's known as just normal control, and you want to add in speed control so you can make it go slower or faster depending on what you want it to do. There's something called analog write, and it only works on these pins that are called pulse width modulation pins. And all of the pins on the NodeMCU are pulse width modulation except for D0, which is 16. And we are using D1, D2, D3, and D4 just for that reason. Let's go ahead and add that in. Instead of having digital write, let's actually just copy each of these except for break. and paste it 2 times. Now, let's go ahead and find digital write. Instead of digital write, I'm gonna add an extra thing here. So this is gonna be slow. Each of these is gonna be slow. So we're gonna add an S to each of these. And this, starting from here, is going to be medium. So we'll put medium. And this one will be fast. And the break will stay the same. Now, instead of having digital write, we're going to have something called analog write. But for the fast ones can stay the same. But what we have to do is we have to change the medium ones. So we change digital to analog write. And we put in a number here. Now the highest it can be is 1023. And we want to take 1023 and divide it by 3. We get 341. So that's what's going to be slow. Medium will be 341 times 2, which will be 682. Let's put in 682 for each of these. Well, actually, sorry. These should just be 0. And we can set these to low, actually. So 682. And this will be analog write. These will also be, these will stay the same, and these will be analog write. Also analog write. And I'm just going to copy analog write for our purposes. This will be 682, 682, 682, and 682. These will also be 682. And now for slow, it's going to be 341. Okay, now let's continue along. So 341, 341, 341. Analog write for both of these. 341, 341. One more to go. 341 and 341. And since we want auto to actually be accurate, let's not make it go too fast. Let's make it go slow. So let's replace these with 341. So that it can so that the ultrasonic sensor actually has time to recognize something. Okay, so that is pretty much our final program. So you can upload now, and you can try it out using your web browser, but I'm not going to do that yet. In the next video, we're going to be building the app. I'll see you then. Bye.